Hi, this is Surajvi here, and today we're going to discuss about the first lecture about software testing, and it is Introduction to Software Testing. So we're going to take a look to the basic concept of software fault, and we are going to understand some sources of errors that may arise, and then we're going to take a look at a basic definition of software testing, what is a good test case, and what are some testing activities that are involved. And in the next lecture, we're going to consider the testing life cycle, the V model, and how they are actually applied in the SDS, that is a software development life cycle. So I assume that you know a little about the software development life cycle, or a bit about software engineering concept before we continue. So, what are faults? Well, if you are a developer, obviously you are human, right? So it depends whether you're using an event-driven software, or let's say an WYSIWYG software. What you see, what you get. So you're obviously not going to have errors in this case, right? Because it's a machine that is populating the codes for you. But when it comes to software faults, I'm talking about developers, right? So errors carried out during the development process. So if there are a large range of errors that is false, you are going to suffer financial loss, right? So it may happen that the customers are going to reject your products, and also if there is loss of lives, for example, in embedded devices, softwares, uh, you may have loss of lives, such as embedded devices in airplanes. So faults are something very, very, very catastrophic, and it may cause financial loss in companies and loss of life. So when it comes to the sources of errors, that is where does faults come from? Now, basically, it may be a human error. This is obvious. Now, we can have some requirements that are wrongly stated. So to just give you an overview, I'm just going to open JEdit and try to talk about a bit about the requirement that may come into play. So let's say you have a requirement where the user actually assume that there is user A, and user A is saying, okay, I need a program that's going to sum up numbers that are single digits, and the requirement engineering, the requirement engineer, that is the requirement engineer, instead of writing this requirement specification into something very clear, he's just going to change this requirement to something like this: a program to sum up the numbers, and he misses this part, the single digits. So what's going to happen is, when you design the program, you're obviously not going to validate your. So obviously what you're going to have is, I'm going to write the program without checking, single digit. Sorry about this grammatical error. So it's going to sum up numbers without taking into consideration whether they are single digit or not. So this is going to mess up around your product. Maybe you will you will evaluate the software, and then you're going to come across this error later on. But a requirement specification may lead to some software faults. Now you can have some flaws in design. Maybe you have set in a class, you have set in your class diagram, you have set your one of your component to private instead of public, and then one of your private attributes to public, let's say private attributes to public, and now you have these flaws in your design document, and this is going to create a problem later on. Now, like I said, testing, when we're going to take a look at software testing definition in some minutes, you have to make sure that testing occurs within the SDLC, that is within the software development deadline. If testing, if the software development deadline is not met, so obviously the product is going to be delivered late. But at the same time, if you don't do accurate testing or adequate testing, that is testing the right functionalities in the system, obviously it's going to make things pretty bad, because the deadline, you're going to miss your deadline, and at the same time you will have most of the component not well test, right? So not all components will be well test. So then you have evolution, that is, you have the concept where you try to fix new software faults, and you try to fix all faults in the software and new faults it is given. Now it may happen that you try to introduce some additional features in the software, and then again you will have to test it, right? So evolution is something very important. Now coming to software testing, if we have to define software testing, what you have to take into consideration is the quality of the software. So what to whom we must prove the quality of the software? It's to the customers, right, for which we are building the software. So if you're going to build the software and there are inadequate testing, therefore obviously it's going to be, the product is not going to be of the right quality. We'll take a look to software quality later on in this series, but for now just understand, with inadequate testing it may lead to bad software. And we were talking about software testing. In software testing is just an investigation that you're going to carry out to prove the quality of the software to the customers, right? And not only this, with the aim of allowing the user, the customer, to accept the software. So we're going to see later on acceptance testing. But when it comes to software testing, there are two important principles in it. One, you have the verification process, and one, you have the validation process. So this we're going to study in the V module. Now when it comes to test cases, when you're going to test a given component, we are going to take a look to the different levels of testing in some coming lectures. So when we design a test case, we must make sure that is requirement traceable. That is, it must allow us to test maybe an FR, that is a functional requirement. Now a test case cannot be annoying. Maybe the test plan is being designed by one person and the other one is going to read the test plan.